Okay, so in the last video, we had kind of left off here, and I had drawn the water molecule. And so what I didn't get into is that with a water molecule, the oxygen atom has a greater electronegativity. And that just means that it's going to pull the electrons closer to it than our hydrogen atom. Okay, so the hydrogen atom only started out with one electron and it's sharing an electron with oxygen, right? Oxygen started off with more and has a greater electronegativity. So it's pulling the electrons closer to it. And because of this, it leaves the oxygen side of the molecule with a slightly negative charge. And it leaves the hydrogen side of the molecule with a slightly positive charge. And it's not, each of those molecules isn't necessarily completely positive or negative because they're sharing. It's not like okay, so this isn't like an ionic bond where the atoms completely give up electrons or completely receive electrons, making that atom now positive or negative. This is still a covalent bond because it's sharing, but because oxygen has the greater electronegativity, it's pulling these electrons closer to this side of the atom. Again, making this side negative and this side positive. So then when we're talking about hydrogen bonds, what happens is the positive side of another water molecule is drawn to the negative side of another water molecule. Right? Oops. So now I've drawn two more water molecules, and then we can have even another one down here. And again, it's just that attraction because the opposites attract, right? So this part is positive. Whoops. This part's positive. This part's positive. And this part's positive. And they're drawn to the negative of the other ones, right? But they don't actually connect. They're just drawn to it. They just hang out near that charge. And that's a hydrogen bond. It's just this desire to be close to the opposite charge. And this is also why polar molecules can be dissolved in water because it'll separate them based on, so if we use, let's use sodium chloride, right? So we have sodium chloride. Well, the water molecules will kind of get in between there and they'll push apart because of the charge. So again, that's a hydrogen bond, is just this being drawn to the opposite charge, but not actually being connected, right? So here we actually have the hydrogen and the oxygen connected. This is a covalent bond, right? Here, it's just a hydrogen bond because it's just the positive and negative sides of the water molecule being drawn to each other. And then the van der Waals connection it operates basically the same way as the hydrogen bond, but it's not a result of hydrogen bonding with something. It's just another electromagnetic attraction, right? So it's another level of a positive and a negative being attracted to each other and wanting to hang out with each other. It's weaker than a hydrogen bond, and a hydrogen bond is weaker than an ionic bond. So that's kind of the breakdown.